Hey guys, so today we're going over the last three types of reactions, and we're also going to be talking about factors that affect reaction rates. So the first one that we haven't covered is called double replacement. And this is actually pretty similar to the single replacement we looked at last week, but it's double replacement. So that means that the elements swap between two compounds to form two new compounds. So two ionic solutions react to form a precipitate, which is a solid, and another ionic solution. So the general form of this is AB plus CD will give us AD plus CB. So this one will pair up with this one, and this one. But the reason why, remember, it's not BC, because C is our metal, so it has to come first, just like our A is our metal, or our positive ion. So if we take potassium chromate and silver nitrate and react, this is one example of it. So potassium chromate plus silver nitrate, and we react it, what are we going to get? Well, our metal over here is going to pair up with our non-metal, or our positive on this side is going to pair up with our negative on this side, and that will give us KNO3. But remember, we have to look at the charges. NO3 has a charge of -1, potassium has a charge of +1, so it's going to be a 1-to-1 ratio. So it's just going to be KNO3, and then our negative over here is going to pair with our positive over here. But again, we have to look at our charges. Chromate has a charge of 2-. Silver has a charge of +1. So we're going to need 2 silvers to cancel out the -2 charge from chromate. So that's what our equation is, but it's not balanced if you notice. We have 1 silver over here, we have 2 silvers over here. We have 2 potassiums over here, only 1 potassium over here. So we're going to have to do some fiddling. Well, that looks like it solves it. So if we put a 2 in front of this one, that changes this to 2Ag and 2NO3. Over here now we have 2 potassium and 2 nitrates. Okay. So the next equation is neutralization. This one you've actually already seen. This is just an acid-base reaction. So this is when you take an acid and a base, and they react to form a salt and water. So remember, our acid usually starts with H, and our base usually ends in OH. This X and this M will come together to form our salts, and our OH and our H will come together to form our water. So both of these are elements. Okay, so if we take sulfuric acid, which is H2SO4, and we combine it with calcium hydroxide, what will it give us? Well, our SO4 and our calcium will go together. Now we look at the charges. Our sulfate has a charge of 2 minus, our calcium has a charge of 2 plus, so it's going to be a 1-to-1 ratio. And then we have OH and H, which will come together to form our water. Now don't forget to balance. We have 1 sulfate, 1 sulfate. We have 1 calcium, 1 calcium. So those are even. But if you look over here, we have 2 hydrogen plus 2 hydrogen, so 4 hydrogen, and we have 2 oxygen. Here we just have 2 hydrogen and 1 oxygen. So we have to times this one by 2. And that will give us our answer. Let's try another one of those. Let's take phosphoric acid, which is H3PO4, and add it to iron hydroxide. So this one's a little bit more of a challenge, because if you remember, iron's a multivalent, but because we see that this has a 2 here, well, OH has a charge of -1, so if this is 2, that means this iron has to have a charge of +2. So we have our iron with our phosphate, and we have to look at the charges. Iron, we decided, had a charge of +2. Phosphate has a charge of +3. So if we switch them, do our crossover method, we have Fe3, and because this is a polyatomic, we need our brackets before we put our 2 down. And then what do we end up with? Well, OH and H, which gives us water. Now let's look at the balancing. 3 hydrogen, 1 PO4. So I've been keeping the polyatomics together just because they show up on both sides. It doesn't work with OH because that's part of the H2O afterwards. So first thing we look at is our metals. So we have 3 iron over here, we have 1 over here, so we have to multiply this by 3. Then our phosphate. We have 2 phosphates on this side, but only 1 over here. Now we have to look at our hydrogens and our oxygens. So on this side we actually have hydrogen in 2 different spots. So we have 12 hydrogen and 6 oxygen. On this side we have 2 hydrogen and 1 oxygen. So how do we go from 2 to 12? Well, we multiply it by 6. We look, 6 times 2, 12, 6 times 1 gives us 6. So now this is balanced. The last type of reaction that we're going to look at is called combustion. And combustion is what it sounds like. It's when a compound or element reacts with oxygen. So this always makes carbon dioxide and water, at least at this level. So our general form is if we take a carbon or a hydrocarbon, so it has carbon and hydrogen, and we react it with oxygen, we're going to get CO2 and H2O. There are other combustion equations, but we're not going to be looking at it at this level. If you take the higher level chemistries, you may. Okay, so if we take methane gas, well, methane, if you remember back to our organic chemistry, methane has 1 carbon. So it's CH4 plus O2 gives us carbon dioxide. This one's not hard to predict the products because it's always going to be the same. The challenge with this is going to be balancing. So we have 1 carbon, 4 hydrogen, 2 oxygen, 1 carbon, 2 oxygen, 2 hydrogen, 1 oxygen. So our carbon is balanced in this one, so we can start looking at our others. We have 4 hydrogen and 2 hydrogen. So let's multiply this by 2. So again, now on this side, we have 2 oxygen and 2 oxygen. So altogether we have 4 oxygen. Over here, we have 2. So we have to multiply this by 2. And now we're balanced. Let's try another one. So an acetylene torch is used to weld metals. So this is actually going to be an ethane, or similar to one. It's only going to have 2 carbons, and we're going to react it with oxygen. And as always with combustion, it's always going to give us carbon dioxide and water. Now we have to balance. 2 carbon, 2 hydrogen, 2 oxygen, 1 carbon, 2, 3, and 2 hydrogen. Let's put this in the right order. Okay, so if I have 2 carbon over here, but only 1 over here, I'm going to have to multiply. That will switch that. 2 times 2 is 4, plus 1, that will give me 5. My hydrogens are even, my oxygens are not. So there's 2 ways to deal with this. I can't go from an even to an odd without using a fraction. So what I'm going to have to do is I'm going to have to multiply everything by 2. So if I multiply this by 2, this by 2, and this by 2, let's see what it does to my numbers. So now I have 4, 4. I haven't touched that oxygen yet. I have 4 carbon on the side. 4 times 2 gives me 8, plus that gives me 10, and we have 4 hydrogen. So if you look, I have 4 and 4, so that stayed the same. I have 4 and 4, so that stayed the same. But now I have 2 and 10. Well, I can multiply 2 by a whole number to get 10. I just have to multiply it by 5. And that will change that to 10. So if you get in a spot where you need a fraction, the easiest way to do it is to multiply all the numbers by 2 first, and then try to continue on. Okay, let's try one more. So this one will actually have oxygen in it. This is glucose. So it is C6H12. 12O6. And again, we combine it with oxygen, and we'll get carbon dioxide and water. This is happening in your body all the time. This is your body breaking down glucose. So we balance it. We have 6 carbon, 12 hydrogen, and 6 plus 2 gives us 8 oxygen. 1 carbon, 2 hydrogen, 3 oxygen. Okay, so if we have 6 carbon over here, we need 6 over here. 6 times 2 is 12, 13. I have 12 hydrogen over here and only 2 over here. So I need to multiply this by 6. 6 times 2 gives me 12. 6 times 1 gives me 6 oxygen, plus my 12 oxygen gives me 18. And now I have 1 left. I have 8 oxygen on the side and 18. So I need 10 more oxygen. So this looks a lot harder. This is easier when we keep this split up as 6 oxygen for here and 2 oxygen over here. If I need to increase this by 10 and I don't want to touch this side, I might actually have to multiply this one by 5. Sorry, by 6. So if we times 6 by 2, that'll give us 12. 12 plus 6 will give us 18, and so now we have 18 on either side. So those are the last 3 reactions, but I just want to briefly talk about reaction rate with you guys. So reaction rate is how to either speed up or slow down a reaction. So there are 3 main ways that we can either speed up or slow down a reaction. And that is going to be temperature, concentration, and surface area. So temperature, as you raise the temperature, you are giving it more energy. If you're giving it more energy, it will go faster. So you're going to increase the reaction rate. The same goes the opposite. If you lower it, you're going to slow it down. Concentration is how much of the reactants you have. It's usually measured in grams per liter. So how many grams of that reactant you have per liter of your solution. The more you increase the concentration, the more of your reactants are there, the faster they can react. But again, the opposite works as well. If you decrease the concentration, they'll go slower, and it will slow the reaction down. Surface area is how much is exposed. So in Science 9, we did the reaction with sodium and water. Sodium, when we do it the first time, it gives us a little bit of a reaction because only one side has not been oxidized by oxygen. So once you've cut it a second time, you've doubled the surface area. Once you double the surface area, it speeds up the reaction, and that's how Mr. Watson gets his really big explosions, is he actually shaves all 4 sides, really exposing the most surface area he possibly can. So as you increase the surface area, there's going to be more spaces for it to react, which means it's going to go faster. Okay, so I'm going to be putting the worksheet in the folder later today. I hope you guys had a great weekend, and I'll talk to you later.